Hello guys, this is a part of wireless LAN video series on securitytube.net. In last video we have seen what all the states present in IEEE 802.11 state machine. There are basically three states. State 1 is unauthenticated and unassociated. State 2 is authenticated but unassociated, and state 3 is authenticated and associated state. Now from state 3 onwards, client and AP can exchange all sorts of packets in between them. In this video we are going to concentrate more on the packets which are getting exchanged between AP and clients in the connection handshake. So these are the main packets which get exchanged between AP and client in connection: the beacon packet, probe request, probe response, authentication from client to AP, then authentication success or failure from AP to client, then association request from client to AP, and association response from AP to client. So in all, these packets are the minimum packets which have to be exchanged between client and AP so that client is associated with the AP. Let's see the importance of every packet one by one. Now first is the beacon. Now AP has to announce that I am present and these are my credentials, like the SSID of the AP is so and so, the channel on which I am operating is so and so, the data rates which I support are so and so, the extended data rates are these, the TIM or traffic indication map information is so and so, whether I support any encryption or not, if I support some encryption, which kind of encryption I support, and so on. All this information AP has to announce so that client will come to know to which AP I should get connected. As well as after client gets connected with the AP, some synchronization for time is required between AP and station. The beacon also serves the synchronization purpose between station and AP. The second important frames are probe request and probe response frames. Now for AP and client getting connected, there has to be some credential handshake. Like if AP supports some minimum data rates, whether client also supports those data rates or not. If not, AP and client cannot talk with each other. So like this, some basic credential check is exchanged between these probe request and probe response packets. Next is authentication packet. Authentication is the way in which AP will find out whether the client is genuine or not. There are two types of authentication. First is open authentication. In open authentication, AP will consider every client which is sending authentication request as a genuine client. And in shared key authentication, which is the second type of authentication, there is a shared secret between AP and station. AP will give some challenge which station will encrypt, and if the encrypted challenge is correct, and if the encrypted challenge is correctly decrypted by the AP, only then AP will send association success frame. Third and the last packet is the association request and association response packet. When client sends association request, client is actually requesting AP that can I share your network resources. Now depending upon the traffic conditions, how many clients are already associated and all this information, AP will send association response as a success that now onwards you can talk with me and we can share the network resources. So the beacon packets are for announcing AP its presence, as well as they are for synchronization. With the help of probe request and probe response, the wireless credentials are getting handshake. The authentication is the basic method of finding the genuineness, and the association is the method in which client is asking, can you serve me? Okay, now let's see a Wireshark trace which contains all these packets for open association. First packet is the beacon packet, which is actually transmitted by this D-Link AP. Now my Intel client has came to know that some AP exists from the beacon packet, and it has sent a probe request which is a broadcast packet on layer 2, and the contents of the probe request are the SSID to which it wants to probe, the supported rates by the client, the extended support rates by the client. Okay. Now in the response to this probe request, AP is sending probe response. Now in probe response, actually if you see the probe response packet, it is very much similar to the beacon packet. The contents of probe response and beacon are almost same, but in the tagged parameters, it will say what all the credentials supported by that access point. So its SSID is so and so, the supported rates by that as access point is so and so, the channel on which the access point is operating, the country information, ERP information, extended supported rates, and all this information. If some encryption is set, those encryption details etc. will be present. Currently it's a open association. In fixed parameter you will see that in capability information you will see its privacy bit to be reset. Okay. Now with the probe response, client will analyze and it will send authentication. So Intel client is sending authentication packet to D-Link client. In authentication packets, you can see the algorithm is open system and sequence for authentication sequence is 1. Authentication sequence is 1, that means client is sending authentication request kind of thing to AP. Now AP will check the credentials. Now in this case, since authentication was an open authentication, AP will simply respond with authentication success and it will set the authentication sequence number as 2. So now AP has authenticated the station. So D-Link is sending that message to Intel. For every unicast packet, acknowledgement is sent. So you will be able to see an acknowledgement for every unicast packet. Now next packet is association request. See, this is an association request sent by the Intel client to D-Link AP. Now let's see the contents of association request. Association request again contains the SSID. Now if you see carefully these supported rates will match the AP's supported rates. If you compare the supported rates in association request and in the probe request, the supported rates in probe request are the supported rates which client actually supports, but the supported rates in association request are the supported rates which are negotiated with AP. So these supported rates will be supported rates for AP as well as for client. So association request, all parameters are the negotiated parameters, and also there are extended supported rates. With the response to this association request frame, AP is sending association response, in which again these supported rates and all parameters will be present. And once this association response is sent by the AP, now AP and client can exchange all kind of 1, 2, 3 type of frames.